Welcome to part 3 of the November 2018 Higher Maths Paper 2. Okay, this is starting from question 15, the other questions are on 2 previous videos. Okay, 3 unbiased six-sided dice are rolled at the same time. Calculated properly, they will all land on a 5. So the probability of one dice landing on a 5 is 1 out of 6. So this is going to be the AND rule, because it's 5 and 5 and 5. So times in. So 1 over 6 times 1 over 6 times 1 over 6. That'll give you 1 over 216. So that's a nice easy 2 marker there. So if you remember the AND rule. Part B, 4 unbiased six-sided dice are now rolled. So we've gone up to 4. So that's going to be 4 fractions. Calculate the probability that at least 3 of them will land on a 5. So at least 3. So if we say sort of f is 5 and n is not 5, the combinations that would work are all 5s. So 5, 5, 5, 5, 5 with and, so times in. But also any combination with 3 5s. So it could be 5, 5, 5 and then not a 5. It could be 5, 5, not 5 and then 5 again. 5, not 5, 5, 5 and not 5, 5. And all of these are separate combinations. Okay, so you cut them all separately, but they are all going to be the same. These 4 here will all come out as the same answer. Right, so doing all 5s first of all, so that's 1 over 6 times 1 over 6 times 1 over 6 times 1 over 6. That's 1 over 1,296. Now for each of these, you're going to have some 1 over 6s, and then for the n, for the one that's not getting a 5 and a 6, one of them will be a 5 over 6. Okay? Now, individually, they will come up as 5 over 1,296, but they're all going to be the same. So this is going to be 5 over 1,296. This one's going to be 5 over 1,296. So is that one. So if you add up all of these now, using the OR rule, because it doesn't matter which one of these actually happened, because whatever happens we'll get at least 3 5s. That gives us 21 over 1,296. Okay, so reasonably straightforward, but write down your combinations on any probability question before you begin. Okay, question 16. We've got a curved graph. It says use the trapezium rule with ordinates. Ordinates are like the edges, the boundaries of each of your trapeziums at 0, 1, 2, 3, 4, 5 and 6 to estimate the area. So for a trapezium we've got A, B and H, and the formula is a half A plus B times H. That's given to you on the front cover. So all we're going to have to do is that 6 times. Okay, so our first trapezium is there. We've got 18 on the left, 20 on the right. Our second trapezium is actually a rectangle, 20 and 20. Then we've got 20 and 18. Then we've got 18 and 14. Then we've got 14 and 8. And finally it's a triangle, but the rule still works, 8 and 0. So if I do one of them, so the first one would be a half of 18 plus 20. The height, which is actually the width because they've been turned sideways, is 1. So that's an area of 19. If you repeat, you should get 19, then 20, then another 19, 16, an 11, and a 4, which gives an area of 89. There's no units on that. It's just a graph. It doesn't really mean anything. If it was a velocity time graph, what you would have just worked out is the distance that something travelled on the graph. Okay, but no units for this one. Question 17. We're at the back end of the paper. We've got triangles. They're not right angles. This is going to be sine and cosine rule. Okay. And you've just got to look at what you've got, really. For the cosine rule, you either need two sides and the angle in between, or, for the rearranged cosine rule, 3 sides. We don't have any of those, so it's probably a sine rule question to begin with. Sine rule needs pairs, and we do have a pair there, okay, and then we've got a partial pair there with the 11, okay. So we're going to start with the sine rule on the left. We can't do anything on the right triangle, we haven't got enough information yet, okay. So if we put our sort of half pair first, we're working out an angle, so angle's on the top, so sine B over 11, that's one pair, is equal to sine 37 over 13. To get sine B on its own, you've got to bring the 11 up and multiply by 11. Okay. You'll have to do sine minus 1 as well after you've done that. So when you've done sine minus 1, you should get an angle of 30.6 degrees. Okay. Then, using opposite angles are equal, we can say that the angle in there is also 30.6 degrees. Now we've got, on the smaller right-hand triangle, 2 sides, the 10 and the 7, and the angle in between. So this is cosine rule now then. So that would be little a, little b, little c, ignore their letters. The 30.6 is capital A. So a squared equals 10 squared plus 7 squared minus 2 times 10 times 7 times cos 30.6. You can use the answer key for more accuracy if you've left it on the screen. Okay. After you've square rooted, because it's a squared equals, you should get 5.3 centimetres. Okay, if you rounded slightly earlier on, you might get 5.4 centimetres. But sine rule first, because we had pairs on the left-hand triangle. Take the angle over to the right-hand side, because opposite angles are equal. And then it's cosine rule, because you've got 2 sides and the included angle, that is the angle in between. Moving on, question 18. So we've got to solve that equation. Okay. It's an algebraic fraction. To solve it, it's going to need to be equal to 0. So first thing I'm going to do is bring the 1 over x plus 3 over to the left-hand side and write it as a takeaway. So 7x plus 1 over 5x plus 2. Take away 1 over x plus 3 equals 0. Okay, now we've got to get our denominators the same. So the first fraction gets multiplied top and bottom by x plus 3. So this is what we had originally, and that goes over x plus 3 there and x plus 3 there. Then we've got to take away. Now we already had a 1 on the top, we've already had x plus 3 on the bottom, and what comes over is 5x plus 2 in the first denominator. 5x plus 2. Okay, right, expand out then the top of the left-hand fraction. That's going to give us 7x squared. We've got 3 lots of 7x and a 1x. So that's 22x. And then we got 1 times 3, which is 3. Okay. Take away 1 times 5x, so 5x plus 2. And I'm going to leave the bottom as it is. You'll see why in a second. So x plus 3, and then x plus 3, 5x plus 2. Remember, this is all equal to 0. Working our way down now then. If I combine this to one fraction by taking away the 2 numerators then, So we've got 5x plus 2, x plus 3 on the bottom. Okay, 7x squared, take away nothing else with x squared in, it just leaves us with 7x squared. Then we've got 22x, take away 5x, so that's 17x. And we've got 3 take away 2, which is 1, equals 0. Now to solve this, we need to bring the denominator up, so all of this here will come up. But because it's equal to 0, when it comes up and multiplies, it will just disappear. So what you're left with solving is that. Now it's calculator paper, it's said to solve to 2 decimal places, so this is the quadratic formula now. So minus b, so minus 17, plus or minus the square root of 17 squared minus 4ac, so 4 times 7 times 1. There's no minuses, which makes this much easier. If there were minuses, you'd have to be very careful. All over 2a, which is 2 times 7. Your two solutions that you should get from there are x equals minus 0.06 for one of the solutions, and x equals minus 2.37, and that is the end of the paper.